So let us see how to do text analytics by extracting features from text to convert it into data that on which we can apply analytics, methods of analytics. So we are going to look at feature extraction and transformation, sometimes what is also called featurization, and see how that enables mining of text or text mining. We'll also look at applications and some of the challenges of text mining, and then get into how to actually convert text into structured data, what is the process involved, and then how we can apply statistical analysis as well as other language specific natural language processing techniques on language and content analysis. Some of the techniques like syntactic processing, named entity recognition, and looking at extra semantic information such as sentiment analysis in this context of doing featurization for text analytics. So, what are these features and how do we extract them and how do we transform them into structured forms on which we can apply the regular methods of analytics? So, typically we tend to assume in any analytics or data science project that the data given to us is already in a structured form. But here it is not so, right? The data comes to us in the form of, not in the form of a spreadsheet or CSV file or tabular form like in databases, but the data comes to us in the form of documents, tweets, reviews, messages, and so on. It could also have embedded images, videos, and other forms. So this unstructured data that comes to us, right, is not readily amenable to analytics, applying the methods of analytics, because those algorithms require tabular data, right? So this kind of unstructured data is more common, more prevalent today after the advent of Web 2.0, because of which social media and blogs and all these things happen, and there is more and more textual and semi-structured or unstructured data today than pure structured data. So how do we apply the methods on this? For example, even if it is structured data, some of the columns may be unstructured, right? Or there may be comments, reviews, remarks, descriptions, and so on structured data, where again the methods of featurization, text analytics may be required. So analysis of unstructured data poses significant challenges, and feature extraction in a meaningful way is critical to doing text analytics or text mining. Right? Text mining is sometimes also known as intelligent text analysis, text data mining, or knowledge discovery in text, and so on. Essentially, it is the process of extracting interesting, non-trivial information or knowledge from unstructured text. Right? So we have a bunch of reviews on a website. We want to arrive at a meaningful score from those descriptive reviews, or you might want to evaluate the overall sentiment in a political or a e-commerce or product or some other scenario. So text analytics uses a number of algorithms. Some of them tend to include ML, machine learning. Here we will focus more on those methods that do statistical analysis with NLP techniques. Right? So how do we convert text into features? It is not only the question of given one text how to extract its features, but how to organize a large collection of text. How do we create textual databases? How do we index them? How do we tag them? How do we order them? How do we cluster them? All of these issues also come up. So there may be complex and subtle relationships within a text, across text, between concepts in the text, and on top of all of this, just like in any other real world data, the data may be incomplete, it may be noisy, it may have veracity issues, and so on. Right? So just to give one example of how ambiguity can be a problem, this is a very well known example. The word apple can refer to the company apple or the actual fruit apple. That's word sense ambiguity and context sensitivity can be a major challenge in extracting the right features from the text. So why do we do this? Some of the applications of text mining is in commerce, customer relations, to analyze customer profiles. For example, a news website continuously analyzes the likes and dislikes and interests and what else that user is doing and so on to figure out which particular news articles to send or feed to that particular user. We do sentiment analysis for movie recommendation, for product recommendation, for e-commerce analysis and so on. There may be information filtering and routing applications. For example, financial news articles need to be routed to the customers within microseconds and milliseconds so that they can take action on that. Or there may be legal search applications, web search, and some other specialized applications like topic identification, topic mapping, simple classification of emails into spam and no spam. All such very practical applications require text analytics or text mining. So how do we actually do this featurization? How do we convert text to a set of structured features, right? A significant amount of pre-processing is required in any of this, right? For example, the text may be in some sense dirty, right? We may have to remove all elements that are not part of the text itself, some kinds of white space, markers, for example, HTML or XML markers, some other foreign words, images, emoticons, some garbage character sequences, punctuation. We may have to normalize upper lowercase text, and then having done all of that, we do what is known as tokenization, right? That is, we split the text first into paragraph, then sentences, then words. Some of them we call them tokens. If there are known tokens, we call them words. Some of them may be not in the dictionary, not in the lexicon, then they are simply called tokens, right? On top of that, we, as I mentioned in the previous lesson, we may classify those tokens or words based on their parts of speech as per the grammar of that language, right? English words may be classified into nouns, verbs, adjectives, adverbs, prepositions, particles, proper nouns, and so on. Okay? And having done that, we may want to remove some of the words, right? I may have a stop list, a list of words that we don't care about, so we may remove them, or we might combine, right, into phrases, and we may use various stemming operations, that is, remove the inflections, morphological inflections such as plurals, past tense, and so on. We may remove, and we may lemmatize, we may do some substitution of synonyms. A variety of linguistic techniques, natural language processing techniques may be applied on the data, right? So the overall process can be depicted something like this. First, we collect data. Documents may be in the form in multiple formats. If it is not plain text, then we have to extract the plain text from it and remove all the formatting information, right? And then we do some parsing in the second stage, which may be starting from tokenization, extraction of words, part of speech tagging, which is called POS tagging, removing morphological inflection, which is called stemming, then word filtering, the substitution of synonyms using, for example, a thesaurus. There is a very well-known resource called WordNet from Princeton University, so you may use WordNet to do some of these operations. Then you do filtering. You may remove some irrelevant terms. You might create, right, custom lists for that particular domain, words that are of special interest and so on, you may look for. And then you do the transformation. We will see what those transformations are. You might count the number of times a word occurs, a term count, right? How many times a particular term occurs within the document or across document. And then You might create a document term matrix or term by document matrix for each term, each document, how many times it occurs in each document, and you might apply various statistical techniques on that, and then you move on to the actual text mining operation of topic extraction, clustering, classification, sentiment analysis, or some other kind of predictive analytics based on this. So we collect the data, we do some parsing, we do some filtering, then we extract based on the features we have extracted, we may apply some transformations, and finally we do the mining. That is the overall process of text mining, right? So when we do this analysis, we might apply regular statistical techniques, right, to quantify the text data, or we might apply special techniques, usually a combination of both language specific and regular statistical methods, right? For example, using language and content analysis, I might identify important structural elements, or I might extract and codify meaning in specific ways. I might use that to do dimensionality reduction, something that I may have to do if I am applying any machine learning technique, right? So let us see how to do this basic statistical analysis on textual data.